Welcome, Antonio and Solo Fellow.
Welcome, everyone.
How are you guys? Give us an emoji on how you're feeling today. Peter, I think we need to start rating your drawing.
I'm getting better.
This looks great.
It's like I'm doing. I'm going to be a graphic artist one day.
Very nice.
Thank you. What do you think, Antonia? Do you think I'm improving? Or do you think there's still quite a long way to go? Solo fellow? What do my drawings get at a score out of 10?
I see Antonio is still connecting to his audio. Solo fellow, can you hear us? I wonder.
Let's have a look. My internet seems fine. It can just be people are busy joining. Let's see the chat.
There
Yes,
we go.
ma'am.
Yes, ma'am.
And there's Valerie. So everyone, we're having a bit of fun. We're trying to rate my drawings. What would you give me as a score out of 10? Like, do I get like a 3 out of 10 or 5 out of 10? So rate my drawing skill at the beginning, and then also do the math. Over here, do this.
Solo fellow rated it a 6 out of 10.
I'll take that. I'll take that. It's a pass.
Thanks for your honesty, Solo fellow.
I'll see if I can up my game for the next lesson. I'll watch a YouTube video on drawing or something. I'm not bad with 3D shapes, but well, I say that now, but I probably won't be able to do it. But you know, when you're a maths teacher, you have to learn how to draw your 3D shapes. So look. Okay, guys. So while we're waiting for everyone to join, if you could please, I know that it's a bit of a mouthful, but have a look at the do now. And I'd like you, in the last lesson, we were speaking about these things called Venn diagrams, which are graphical ways of seeing collections of things. And I'd love to see how things can go. Just do what you can from this old exam question. Just see how it goes. And we'll talk some more about it in a moment while we still welcome some people. Okay.
So welcome to Zimi, to Antonio, to Tato. And we've also got Coco joining us. It's
welcome, Coco.
Welcome, Coco.
There we go. I'll give Coco a special shout out because Coco is part of the team. Can she hear us? Okay, so while we're waiting for everyone, your attention is on the do now question. And the topic is there are 24 learners in a class. We're invited to Adam and Nisha's birthday parties, and then there's a bunch of questions, A to D. Okay. Now, welcome, Zimi. I'm definitely recognizing the names, which is fantastic. I'm starting to get to know you guys. Remember to put your name in the profile if you can, just so I can call you by the right name. Okay. All right. I think I'm pretty much ready to get going. I think we need to. Anything from you, Ozan?
Nothing from me. I just sent something on the chat to everyone. So yeah, enjoy. Then I'll see you guys afterwards.
Awesome. Okay. So I just want a quick thumbs up, thumbs down vote. If you feel like you know what to do roughly, you're not done yet, but you know what to do, give me a thumbs up looking at the do now question. And if you feel like I don't even know where to start, please like help, whatever, give me a thumbs down. Okay, so I'm going to watch that because I wanted to start with a slightly more difficult one today, but it's not impossible, just to see how much we remember from the previous lesson about Venn diagrams. And Venn diagrams, like I said, are a way of taking collections of things that can be quite complicated as numbers, but a lot easier to see the relationships if we see them visually. Okay, so I'm just waiting to see. Thumbs up if you feel like you know how to get started with this one. Thumbs down if you feel like you don't even know where to begin. Okay, good. So if you do know where to begin, okay, I see those hands, keep them coming. I want to know how you're feeling. For those who know, if you feel like they can get started, I want you to get started. I'm gonna give you a little bit more time here because this is a proper question list. Okay, so we have A, B, C, and then D has 3 parts to it. 1, 2, 3. And so what I'm going to do is I'm just going to go through the words. 24 learners in a class were invited to Adam. So let's say A for Adam and N for Nisha. 13 decided to go to Adam's party, and 12 decided to go to Nisha's party. But 3 learners decided to not go to either of the parties. And they don't actually say what, but there's a 4th possibility, and that's that some people could have actually gone to both parties. So some people like to go to both parties. Okay, so I want answers for A. How many learners went to the 2 parties in total? I want to see the chat light up. Or I want someone to shout it out for me. What's the total number of students we're dealing with? Which would be the answer to A. Either the chat or just jump online, chop, chop. Okay, so the most important number, in probability, it's always like the total number of possible outcomes is an important idea. There's 24 learners in a class and they were invited. And so that's the base number that's going to go inside our Venn diagram. How many learners went to both Adam's party and to Nisha's party? Okay, this is a little bit, oh, well done, sort of fellow. So the second question is a little bit harder because they tell us that 13 learners decided to go to Adam's party and 12 learners decided to go to Nisha's party, but they don't say how many learners went to both. Now, I want to try and use this 3 learners over here that decided to go to neither of the parties. And there's an important identity in sets that we can sometimes use. I'm going to actually make it a bit bigger just to focus on it. Let's actually bring it up a little bit. And you may have seen this in class that, actually, maybe it's a bit too big, but often you see teachers talk about this thing, number of items in A or B is the number of items in A. Make this bigger. With too many windows open here. This is called the additive identity plus the number of items in B minus the number of items in A and B. Well, that sounds like a bit of a mouthful, but if you think about this, well, the way this would work is if, for example, A and B are just A and N. So there's 13 people decide to go to Adam's party, and 12 people went to Nisha's party, then you can kind of start to work out this from this idea. How many of them went to either of these? There were 21. Okay, probably maybe actually It's a little bit confusing way. Let me do it another way. But that identity can be used. Okay. If I said to you, what is 13 plus 12? It's going to be 25. Okay. And the 13 and the 12 came from here. You know, there were 24 people in the class in total, but 3 of them didn't go to either of the parties. Okay. So there's 21 people who went to, basically who went to one of the 3 groups, and you've got the 25 here. So what is this thing telling you? I actually find this easier to see in a Venn diagram. So I'll show this to you in a Venn diagram in a moment. What's the difference between 25 and 21? It's going to be 4 students, right? So you know that there must have been 4 students who went to both the parties. Maybe another way of thinking about this is, in fact, I'm going to draw the Venn diagram, which is question C. So let's say this is A. These are the students that went to Antonio's birthday party. And then this is going to be N, the students that went to Nisha's birthday party. Now, you know, in total inside the rectangle, there are going to be 24 students. But you know that 3 people went to neither of these 2. Okay. Can you see how I know that there must be 21 students inside of this area? Give me a thumbs up if you understand why there's 21 inside the area I'm highlighting. I just want to see I'm not losing you because I know it gets a bit abstract. Am I seeing a few thumbs? Okay. Now, if you think about the fact that how many must be sitting inside of here? Well, you know that in total there must be 3 plus 21. Okay. Now, the way that I can think about this one over here is that from above, I know that there were 4 students who went to both of them. And so if Adam's party was 13 there, what's this going to be? Well, 13 minus 4, that's going to be 9. And then for N, for Nisha's party, that's going to be 8. Now let's see if that adds up to the total. 3 plus 9 is 12, plus 4 is 16, plus 8 is 24. That's all good. 9 plus 4 is 13. And then 4 plus 8 is 12. And so all the different things are worked out fine. Okay, so we're going to put a 4 here, and then the Venn diagram is drawn over here. Now, the last one that I want to do is I want to say, connect the probability. It says one of the 24 learners is selected at random. What is the probability that the learner only goes to Adam's party? So, only goes to Adam's party. What region is that going to be? Well, and also, what is the total number of learners? There's 24 possible learners. In all these questions, there's only going to be 24 possible learners. And then I have to ask myself, how many people are in the favorable outcome? So if you go only to Adam's party, what region is that going to be? I think the region that going only to Adam's party is going to be those 9 there. And so I'm going to put a 9. Now, if I work that out as a decimal, I would just use my calculator. For the next question, that the learner goes to both parties, well, that's going to be this region over here. And so it's going to be 4 out of 24. And that the learner doesn't go to either of the parties, well, that's going to be this region out here. And so the answer is going to be 3 out of 24. Okay. So we'll do another one like this, but that's just a sort of warm-up question with the Venn diagrams. And just to review, in the previous lesson, let me just make this a bit bigger. We did Venn diagram, sets, and probability. And as we go to today's lesson, what we're going to focus on is more Venn diagrams. Let's make this a bit bigger. So home. More Venn diagrams with bigger sets. So that's the focus today. More sets and probability vocab. tree diagrams, contingency tables and events, and then a general review. So that's what we're going towards. Okay. Let us look at another Venn diagram task. And you are going to help me with this one. Let's get rid of this. So, can everyone see the question? Give me a thumbs up if you can see the question, or give me a like jump on and say I can see it. Is it clear? Okay, fantastic. I'm going to give you 3 minutes or so to see how this goes. This is another type of exam type question dealing with something called complementary events. And I want to see how your Venn diagram skills are going on this one. Welcome, Asamakle. I see you in the house. And we've welcomed everyone else. I think. Antonio, welcome. Okay. Okay, so in this question, there are 27 girls, and that is the main big number. 10 play netball, and the rest do not play netball. Okay, now how many in the group of girls do not play netball? So these are complementary sets, and we call them complementary because there's only 2 options, and together, essentially, they're one or the other. So if you're in N, the only other set you can be in, okay, essentially, if you're not, it's going to be N dash or not N. So if you've got 27 to start with and 10 play netball, how many do not play netball? It's just going to be 27 minus 10, which is 17. Represent the information in a Venn diagram. So there is my sample space, and I'm actually only going to have one main set I'm worried about, and I'm going to call that N for netball. And then I'm going to change my color. And how many people play netball? There are 10. And then we know the ones outside of the set, or not in, or the complementary set, is going to be 17. Are the events play netball and do not play netball complementary? Okay, I kind of given that one away. They are, because together they fill the whole sample space and they are mutually exclusive. So another word that comes up is mutually exclusive. Would anybody like to be willing to share their own definition of mutually exclusive? What does it mean if we say 2 sets are mutually exclusive? Who's feeling brave to add some human voice here, or some other human voices? Asamakle, Valerie, what do you think mutually exclusive means? And are these 2 sets mutually exclusive? Okay, give you a moment. So mutually exclusive means if you do not play netball, you can't also play netball at the same time. So essentially, these are mutually exclusive, and they're complementary because there are only 2 options in this experiment, the situation. So are the events play netball and do not play netball complementary? Yes, they are. Determine N of S, where S is the sample set. So in this case, this is going to be 27 because S is the biggest set possible. It's the whole Venn diagram, and there's 27 items in that. And then E, one of the 27 girls is chosen at random. Determine the probability as a common fraction that the girl plays netball. Well, the netball players are going to be 10 out of 27, and the do not play netball is going to be 17 out of 27. And you will see that together, these two things add up to 1. So it's certain that either in this group, somebody either plays netball or they don't play netball. And that's on the probability scale. Okay, let us move on. Now, actually, before I move on, let me go back. That was a bit quick. Are there any questions before I move on? And Alzan, just let me know if there are any questions in the chat. I can't see that much today. I'm still figuring out where all my windows go. Okay, now I want another vote from the audience. Have you ever done Venn diagrams with 3 circles before? So put your hands up and a thumbs up if you've done Venn diagrams like this before, and thumbs down if you've never done Venn diagrams like this before. Okay, I see a few thumbs. Don't be afraid to use your thumbs, people. This or this. Aha, okay. I see a couple of thumbs up, a couple of thumbs down. Okay, so I'm going to walk you through, we're going to do this together. It's not so different, but it's, you know, it has some ideas. You want those who have done this before, do you want to give us a few hints, a few things that you found helpful when you first saw Venn diagrams involving 3 different events? Like in this event, just to set the problem up, it says we can solve probability problems involving 3 events using Venn diagrams. And in this event, there are 350 learners, and the sports being considered that they play are tennis, rugby, and cricket. Now, I think, Zimi, I think you said you may have seen this before. Could you give us some tips about what you found helpful?
Yes, to plot the one they all have in common first. So, for example, it says 78 like all 3 of these sports. To plot that one first so that you can subtract it from the other groups.
Okay, this is very important. So, okay, so that's probably the most important thing. If you get that, everything else becomes easier. Now, just before we start putting numbers, the idea of a Venn diagram is just a visual representation of the relationships between these collections of things. But sometimes when we have collections, we get people who belong to more than one group. And so keeping track of them and counting can be tricky. But if there is, and this is what you scan for, you see, is there anybody who plays all 3, who is in all 3 events? Now, it says here, there are 78 like all 3 of these sports, which means there will be, in these 3 events, there's one event, there's one group that has all 3, there's some people that belong to all 3 events or all 3 families. Visually, you could see it as this group of people over here. They're in all 3 circles. Now, that's a very important thing to bear in mind, because if you do that first, it makes life a lot easier. So I'm going to set you guys up. And we'll make, what should we make this one? We'll make it, do that one, and we'll give each of these a name. We'll call this one tennis. We'll call this one rugby, and we'll call this one cricket. Okay. 350 learners. Now we know there are 350 people who fit inside this diagram here. Okay. Now, I want you, before I even give you anything, I want you to try and fill out the Venn diagram by yourself. See what you can do. How many people do you think go in here? How many people do you think go in here? And then I'm going to come along and I'm going to suggest what I think it is. But I think you've got enough to fly solo on this first. And remember Zimi's tip. Where do we start? We start with the one that has the most in common. So where was that? 78 like all 3 of these sports. So we're going to put 78 over there. to start with. In fact, if you need to, you can even start by going like tennis only. Okay, so tennis only. Now, we can't fill out tennis only to start with, because can you see, we know that there are 180 people in that area, but there's 3 different other regions, so we can't actually use that information yet. We actually need to go from the most specific to the, I think what we need to do is we need to start with these ones down here, because these ones are too vague. So let's have a look here. So 60 like tennis and cricket. 60 like tennis and cricket. Is that right? Tennis and cricket. Where would tennis? But not rugby. Ah, okay. So 60 like tennis and cricket, but not rugby. So tennis and cricket, but not rugby. I think that's telling me that this is important, because if you get this, everything else will make sense. I'll get a red pen to make it a bit more standouty. Come on, colors. They're not behaving. Okay. 60 like tennis and cricket, but not rugby. Now, rugby is this circle here. So I can't be in that circle. 60 liking tennis and cricket is going to be, that's going to be 60. Give me a thumbs up if you understand why that region has to be 60. It's very important. I don't want to go on until I see that you guys understand where I got the 60 from. So I want to see some more thumbs up. 60 like tennis and cricket, but not rugby. Okay. Now, the next one, 54 like cricket and rugby, but not tennis. Okay, so it's always very confusing because there's a lot going on. But if you just slow down and look at it visually, 54 like cricket and rugby. So cricket and rugby, what region is that? Cricket and rugby is going to be here. Cricket and rugby, but not tennis. So I can't be in tennis. So this is going to have to be 54. And then 30 like tennis and rugby, but not cricket. So 30 like tennis and rugby, but not cricket is this one here. Can you see how, following Zimmy's idea, we work from the inside out? So the things we've got left to figure out now are that one, and that one. I want you to try and figure that out by yourself. I'll give you a moment because it's quite a good feeling when you do it independently. What have we not used? Sometimes I tell my students, cross out the information that you've used already so you don't get distracted by all these other things. So the only information you've got left is this. So we need to use this. How can we use this to figure out? And you may even need a calculator. So 180 like tennis. Now you already know a whole bunch of things about tennis. You just want to find the remaining stuff. So I'm going to go, let me show I'm right, 180 minus all these guys. So I'm going to do it with my calculator because 180 minus 30 minus 78 minus 54, and I get 18. And then for cricket, so we've done tennis. For cricket, I've got 240 minus 60 minus 78 minus 54, and I get 48. And then for rugby, I got 180 minus 54 minus 78 minus 30, and I get, did you guys get 18 as well?
Yes, but for the T1, I got 12.
Aha, let's see if I made a mistake there. So tennis, 180 minus 30 minus 78 minus 60. I get 12 as well. Thank you, Zimmy. So now there's one more thing I've got left. I need to figure out what's out here. How am I going to figure that out? So if you think back to the very beginning, what was the total number of items that goes inside the sample space? Wasn't it 350? So to work out what's out here, all I need to do is subtract all of the items inside here. Now, that's going to be 350, and we have to be careful here. So minus 12, minus 30, minus 78. So what that's minus 60, minus 18, minus 54, minus 48, and I get 50. And I can actually check my answers. I've got the answers on the side here somewhere. But yeah, there's the right answer. It's 50. Okay, so I know it's a lot of hard work, but again, if you work from the inside out, that's really, really important. And once you've done that, then the probability stuff is quite easy. So if we look at these probability questions down here now, okay, calculate the probability that one of the learners chosen at random likes rugby only. Well, all we need to do is say how many students in total are there? There are 350. How many of them like rugby only? I have to find the region. It's going to be the students over here. And so my answer is going to be 18 out of 350. If I punch it into my calculator, I get 0.05 or 5%. Or 5% probability that I choose someone at random who likes rugby only. What's the probability like that likes none of these sports? Well, again, what is the region I'm dealing with? For none of the sports, I think that magic number is going to be 50 divided by 350, and that is going to be 1 in 7, or about 14, 142, which is 14%. Okay, and this is a proper exam question. So I've spent quite a bit of time, so I just want to get a feel. Thumbs up, thumbs down. Give me a quick thing of how you're feeling. I know it's not perfect. You can still practice more, but I hope that gave you a feel for kind of the basic idea of how we work through a more complicated Venn diagram. Okay, awesome, guys. I want you to stand up. We've been talking quite a lot, and I know, so I want you to do a little stretch, a little rotation, and just maybe even just stand up for a second, get your body moving so that your brain has a bit of a break. Because I know from sitting here that if you just stay sitting, your brain kind of goes to sleep, and we don't want that. We want our brains to be nice and awake. Okay, so the last major sort of diagram that you need to know how to draw for probability is something called a tree diagram. And what a tree has is it has branches, and then it has things along those branches. And the main reason that we use like graphs and various visual descriptions of things is sometimes it's complicated to do the calculations only with numbers. And so as mathematicians, what we do is we develop structures that make it easier for our brain to process the information. And so a tree diagram, like what it says here, let's even read it. It says, when listing the combined outcome, when listing the combined outcome of 2 or more activities, using a tree diagram is often the easiest method to use. We can use a tree diagram to work out combined outcomes of events that are either independent or dependent. And there's some more words there that come from probability and statistics. So independent means the two are unrelated, they don't affect each other. And a dependent event is the one event affects the probability of the other. Okay, and so the example that often we use is if you throw one dice and then you throw another dice, the results of those two are independent of each other. They don't affect each other. But if you're drawing something out of a hat, let's say a collection of items, and you take one item out and you draw it, and there's a probability of getting red, and you take something and you put it on the side and you draw again, the fact that you've taken something out of the hat affects the event of drawing again. And so we say those two events are dependent. So that's a quick little feel for it, but I'll show you more in an example. And we're going to do this example together. Okay, so quick show of hands. If you've done a tree diagram before, give me a thumbs up. If you haven't done tree diagrams before, give me a thumbs down. Okay, so thumbs down, thumbs up. Okay, thumbs down. Okay, thumbs up. So it's about an even spread. So the main idea is that the tree diagram helps you see the number of outcomes. So whenever you calculate things in probability, you're always interested in how many possible outcomes are there, and then how many favorable outcomes are there for the question we're asking. And then in some cases, which of the outcomes are more likely? So one outcome might have a probability of 30%, whereas another outcome has a probability of 15%. So the one is more likely than the other. And so how do we keep track of all these choices is the main idea. Okay, so it says here, suppose a family has 3 children, okay, which is not unusual. I come from a family of 3 children. I have 2 sisters. There are many combinations of boys and girls that can make up these 3 children. Draw a tree diagram to find all the possible combinations of 3 children in the family. Okay, so each time someone is born, there is an option. So let's go, we can go first, and we're going to go boy, girl. Okay, so that's the first outcome. Then the other outcome, in fact, I want you to do this. What do you think the rest of the tree diagram looks like after that? I'll give you a moment to draw that in for yourself before I come in. So if my first option is boy, girl, if I want to keep track how many possible outcomes there are, I think that the second child can also be boy, girl, like that. And then the third child can also be boy, girl, boy, girl, boy, girl. Okay. So I know this is quite a lot here, but essentially what I have here is, it looks to me like the one combination that's possible. Let's use a different color. Or in fact, let me use my magic highlighter. If I look at this option, that is the choice. And maybe you know some people who are, there are 3 boys in the family. So that's one of the possible options. Another option is 3 girls. How many total combinations are there? Let's count them. How many unique combinations are there? So let's call that 1. Boy, boy, girl is 2. Okay. Boy, girl, boy. What if I've done this a little bit? It's a little bit messy to see what's going on here. Boy, girl, boy. Boy, boy, girl. So this second one is actually the same combination. Can you see that? Probably going to confuse you a little bit. Let's draw here. So what I've noticed is there any difference between, let's just read the question, all possible combinations of 3 children? So we have to decide, is there a difference between boy, boy, girl and boy, girl, boy? I don't think there's a difference. I think that for this question, that doesn't count as a separate option. But boy, girl, girl does count as a separate option. So that's 3. Girl, boy, boy doesn't count as a separate option. So maybe, let's have a look. No, that doesn't count as a separate option. So there's still 3. Girl, boy, girl is a separate option. Have we got that already? No, we've already got that. Girl, girl, boy, we've already got that. And then this one here is 4. Okay, I may have had it. Let's actually bring up my answers here. Because I think I've probably made it a little bit confusing with my drawing. Let's have a look. Eraser. So the main idea I wanted to show you with that was just that you're going to lay out the information in a way that is hopefully easy to see, but I'm going to go to my, okay, at my solution here. to help you out. Okay. Okay, so actually I was going on a bit of a wild goose chase. In terms of this question, they are saying that that one and that one are different. So I actually got a bit distracted by something that is, in this case, they're saying it's different if there's the eldest is a girl and then the two youngest are boys. We don't actually have to try and match them like I was doing. Okay, so that's something, if you're feeling a bit confused, there are actually 8 options involved. So we've done a tree diagram, then determine N of S where S is the sample space. N of S is 8 because there are 8 different outcomes on my tree diagram. Okay, so no problem there. Use a tree diagram to figure out the probability that all three children are girls. Now, out of the options that are here, only one of the 8 options corresponds to that. And so we get the probability of all girls is just going to be 1 in 8. Okay, so that's that one. But I'm going to do this question for you, then we can do the next one together. The probability that all 3 children are of the same gender. Now, what does that mean, of the same gender? What do you think the probability for that one's going to be? Well, the same gender is going to be the girls only, but it's also going to be the boys only. And so what we see is that will be the option 2 out of 8 or 1 out of 4 or 25% probability. Then for 3, the probability that at least 2 of the 3 children are boys. Okay, that's a bit of a mouthful. We know that there are 8 total options. At least 2 of the 3 children are boys. So which of these ones is going to count for that? So at least 2 of the 3 children are boys. Well, I know the top one is counting. That one has 2 boys. That one has 2 boys. That one has 2 boys. Do any of the other ones have 2 boys in them? Let's have a look. So at least, now I can count, you may say, how do I count the third one, boys, boys, boys? Well, at least includes all 3 boys. And so the answer for this one is going to be 4 out of 8 or 50%. And then the fourth one, the probability that one of the 3 children is a girl. Okay, so again, we've got 8 in total. How many of these options have the probability that one of the 3 children is a girl? Now, I'm only looking for the situations where one of the 3 is a girl. So let's have a look. That one is going to count. Oh. That one is going to count. That one is going to count. That one is going to count. And that's it. These are the only ones that have only one girl in the family. And so the probability of that is 3 out of 8. Okay. Now, if that's the first time you've seen this, don't worry if you're feeling a bit confused. You need to spend quite a bit of time setting up the drawing and then understanding what are the possible outcomes and then asking yourself, what are the favorable outcomes for the question? So a favorable outcome in this last one would have been there's only one girl in the option. So that's why only these were favorable outcomes for that question. Before I move on, I know you guys have been a bit quiet today. Is there anything else before I move on from this question? Are there any comments or things you want me to consider? Okay. Let us do this one together. Now, the only difference here is not all of the outcomes are equally likely, but I want you to draw the tree diagram for me first, and then we'll take it from there. So it says, Teddy has 2 pairs of black shoes and 3 pairs of brown shoes. He also has 3 pairs of red socks, 4 pairs of brown socks, and 6 pairs of black socks. Now, in this particular case, you are choosing between shoes and socks. So you're not choosing between children. So that's the first thing I want to emphasize. And I want you to try and draw me a tree diagram where you have all the option for shoes and then you have all the options for socks. And then what we're going to do is we're going to actually use the tree diagram to write in probabilities. Okay, so take a moment. Can you draw a tree diagram that relates to this question? I'll give you a moment or two. In fact, you know what? I'm actually going to give you a hint. There's only two choices. There's black shoes and brown shoes. So I'll start you off with that. So we'll say black and brown. What are the choices for the socks? What do you think is going to go here? So we've taken care of that, although we need to talk about the probabilities of each of these occurring. What are my options for the next thing? There's red, there's brown, and there's black. So I think we need a red, a brown, and a black, and a red, a brown, and a black. So if we look at our options here, how many different options or how many outfits are there? I want you to put a number in the chat or jump on. How many different, combinations of shoes and socks are possible? I'd love for you to put that in the chat. And then the goal is eventually to answer the question. But for now, how many different options? You've got black and brown shoes, and then you've got red, brown, and black socks. And I want to know how many combinations are there? How many choices of the outfit are there? If I had black shoes and red socks, that would correspond to this one over here. Black socks, red shoes. This one, black socks and brown shoes, would be number 2. What is the total number of options I have? Anyone know? You can shout it out. Tumelo, Trent, what do you think? How many different options are there? Ah, you people are on the ball. You're right. Okay, now, the next thing. Are each of these options equally likely? So I'm going to say it again. Are each of these options equally likely? In the last question, they were, okay, because there's nothing, affecting, the chances of boys and girls. But in this case, is it equally likely that you would randomly choose black shoes or brown shoes? Let's read the question. Teddy has 2 pairs of black shoes and 3 pairs of brown shoes. So if you think they're equally likely, I want you to put thumbs up. If you think they're not equally likely, put thumbs down. Because this is important. When we consider the different outcomes, there are 6 outcomes that are possible, but I want to know, are they equally likely? And so thumbs up if you think they are equally likely, thumbs down if you don't think they're equally likely. Okay, so I see a combination of thumbs and hands, which is fine, that's perfect. Okay, what we often do with tree diagrams is on each branch, we write the probability of getting that outcome. It helps us keep track. Now, if you have 2 pairs of black shoes and 3 pairs of brown shoes, in total, you have 5 pairs of shoes. Now, the chance of choosing black shoes is going to be 2 out of 5. And the chance of choosing brown shoes is going to be 3 out of 5. Now think about that for a moment. If you've got 5 pairs of shoes and you randomly put your hand into the cupboard and you choose, it's actually more likely you'll choose brown shoes if you look at probability. Now, after you've chosen your shoes, you're then going to go put your hand into the sock drawer. And now you have another choice. And I want to know, do you think it's equally likely that you will get, do you think it's equally likely you'll get red socks, brown socks, or black socks? Or do you think it's not equally likely? So thumbs up if you think it's equally likely, thumbs down if you don't think it's equally likely for the socks. I think some of you may be feeling a bit confused by what I'm saying. Okay, all I'm going to say is this: is once you've chosen your shoes, your socks choice, how many socks are there? There's 3 pairs of red socks, 4 pairs of brown socks, and 6 pairs of black socks. So let's write this up. 3 plus 4 plus 6. So that is going to be 13 pairs of socks. So I think the chances of getting red socks is 3 out of 13. The chances of getting brown socks is 4 out of 13. And black socks is 6 out of 13. So it's more likely that you will choose black socks because there's just more black socks in your drawer. And the probabilities are going to be the same for the second branch of the tree. Okay, now, like we said at the beginning, let's try and answer this question. This outcome over here, outcome 1, the way you get the probability of working out what this is you multiply along the branches. So outcome 1's option is just going to be 2 over 5 times 3 over 13. And you can use your calculator, or you can just use good old maths. There's a 6 out of 65 chance of getting that branch. Now, I want you to try and answer this question for me. Let's go back to the question. If Teddy chooses a pair of shoes at random and a pair of socks at random. So what that means is I'm closing my eyes, I put my hand into the cupboard, I grab some shoes, and now I put my hand into the drawer, I grab some socks. And what is the probability that he chooses shoes and socks of the same color? Okay, which of these options are going to have the same color? Let's have a look. Black shoes, red socks. That is not a favorable outcome for what we're trying to do. Black shoes, brown socks, also not a favorable outcome. Okay, so both those first two, we don't really care about at the moment. Black socks, black shoes, I do care about that. And so the possibility of that happening is 2 over 5 times 6 over 13. So that is happy face. Now, what about the next one? Well, if you follow this basic idea, I think you'll see for the same reason that doesn't help us, brown and brown does help us, and brown and black doesn't. So I want to know what the probability of this region, this one over here is, and that is 3 over 5 times by 4 over 13. And so now these two are the two options. I need to add them together. So what do I get? I get 12 over 65, and you can use your calculator, and you get 12 over 65. But now each of these options is valid, and so I have to add them together. So what do I get if I add 12 over 65 plus 12 over 65? I get 24 over 65. Is that one of the options? Yes, it is. Okay, and so that was a harder tree diagram question, but a couple of key steps. The key steps are as follows. First, draw your diagram with all the options. And that doesn't even involve maths. That's just pretty art. Once you've done that, you put numbers on each of the tree's branches. And that's especially relevant for when the outcomes aren't equally likely. And then after that, you calculate the probability for each branch. So all you need to do is multiply along the branches. That's the probability of that one. That's the probability of that one. And ask yourself which of those branches are relevant for your question. Okay, so can I have a quick thumbs up, thumbs down? Are you feeling like that was sort of helpful, or thumbs down, you're like, oh, this is still like, I need to get going?
So it's going good.
You like it?
Yeah.
That's fantastic. Okay. I'm going to squeeze in one more question about something called contingency tables. Now, I could do more tree diagrams, but I think if you go back and practice by yourself, we've done enough that I've laid the foundation. I want you guys to try and do this. Sometimes they give you information in what's called and I know we're almost done, but if you could just hang in with me. I want you to try and complete this table. Now, this is another way of showing the number of outcomes, and it's called a contingency table. And the two things that we're thinking about really are gender, boys or girls, and favorite sport. Okay, so, and I want you to fill out these columns, and this is a very common exam question. Ozan, we're running a little bit late. Can you give me can we run 2 minutes over or 3 minutes over?
No problem, Peter.
Okay, cool. No powers going out tonight or whatever.
No power, no load shedding tonight. No.
Fantastic, and hopefully also for the students. Otherwise,
Hopefully.
we'll say goodbye to the students quick. Okay. So, how many boys choose athletics? Really, that's just going to be this column over here. So that is going to be. Wait, I lie. How many boys choose athletics? I must concentrate here. It's going to be 4. Boys, athletics, that one. What was the most popular sport for boys? It's going to be football. Okay. How many girls are in the class? I look for the girls row, 5 plus 4 plus 7. And so it looks to me like there are 16 girls in the class. How many pupils are there in the class in total? I want you guys to show me in the chat. $31. Okay, so there are, if you count along the outside here, you would say there's 15 boys, 9, and then plus 7 is 16, which means there's 31 girls in total. Okay. Now, we haven't got through every type of question that is possible in this section, but often what they do in these types of questions is that they ask you about events being independent and dependent. And so what I would suggest is in the exam questions, just a little promo. Next week, we're going to be doing an exam preparation course. And what I'm going to do is I will finish off, well, I'll start that exam preparation course with a look at a data and statistics question. And I just want to comment a little bit more about something called independent and dependent events, which relates to contingency tables. But I'm not going to try and squeeze it in now because I feel like we've done a lot of good work today on Venn diagrams and on tree diagrams, which are important ways of looking at questions of uncertainty. And I want you rather to consolidate that work. Okay, so well done, everyone. Please do come back next week. I know a lot of students are cramming for the exams, and please do tell your friends because I think we have a nice group going and we can definitely add some more faces. And yeah, Alzan, I'm going to hand back to you and thank you for being with us today.
Awesome. Thank you so much, Peter. So I'm just going to add something to the chat box. You guys can just hop in there and rate your experience of those 8 lessons. Please feel free to be honest so that we can know for our next lessons how we can help you better and how we can help you improve. And then I'm also going to share my screen. Yeah, sorry, Peter, I tried the poll, but that didn't happen.
No, it's fine. Don't worry. Don't worry.
Okay,
that's perfect.
So let me share with you guys. So this was our last lesson on stats and probability. And because you guys joined all 8 lessons, for those who only came in later, that's absolutely no problem. Thank you for joining. And yeah, we still are very grateful for just seeing you guys participating and learning, and hopefully we'll see this in your reports. We can't wait to hear how your exams went. But here's a shout out to all of you who joined. This is a dancing man for you guys. So yeah, this is just a shout out to you guys. Well done for completing your 8 lessons. And if there's anything that you got stuck with, be sure to go back into Watobe's app and go do some revising there. And then lastly, I just want to congratulate all the learners who's done their lessons. So well done to Lishle and Sipo for the 5 lessons that you've completed on the app. And then for Tumelo, Valerie, and Tokozani for the 4 lessons. And then for Asemashle for the 3 lessons. Yeah. Great job, guys. And then that's all from my side. Next week, Peter will be starting the exam prep, if I'm correct.
Yeah. So, I mean, I can even give a little bit more detail. So basically, grade 11, normally paper 1 and paper 2. The first 2 lessons will be focusing on paper 1. The second 2 lessons, paper 2. And yeah, we'll just be taking old questions and trying to, I'll outline how teachers set exams, the different types of questions, and how you can best approach the exam. And yeah, so it'll be a broader content base we'll be covering. Yeah.
Awesome. Thanks, Peter. So I hope you guys got that. And then also just to go onto the chat, so I see some of the feedback is saying that the only problem that was you weren't able to attend from Tumelo. Okay, that's a 4. So no worries. If you weren't able to attend all of the lessons, be sure to hop on Watobe's YouTube channel, and then you'll see all the live recordings. Okay, so you can get some work, or some of the work that you missed, you can just go back to that.
And especially if they're missing a particular topic, they can always look their headings on the videos. So you can look for, like, if you're weak about something, look for that heading.
Yeah. And then we've got a lot of 5s and a 4.5 from Zimi. Awesome.
Okay, no, I'm glad. I mean, again, you feel free to be completely honest, but so it does seem to be helping you guys, which I'm glad to hear. It's quite hard to judge on this side, but I've been having fun, so I hope you have.
Awesome, guys. Well, thank you so much for your feedback, and we hope to see you guys again soon. All the best for those who's writing exams. Study hard. Just know that Watobe and the team's rooting for you, and we're excited to see you guys again.
Totally. Cheers, everyone.